Hi guys, welcome to Unit 6. We only have 3 units left and then you're done with the semester, so that's super exciting. But yeah, so Unit 6 is all about systems of equations. And Lesson 2 is called Solving Systems of Equations by Graphing. So we're going to be looking at multiple ways to solve systems of equations throughout this unit. Okay, and this one is nice because it's visual, all right? So it's a little easier to see. So we're going to be using something called intersection point, all right, which is the location of the common point of the graphs of equations, which really means where do they cross, okay? That's what that's referring to. And then systems of linear equations is a set of 2 or more linear equations, so equations when they graph, they turn into lines, that have the same variables and are graphed on the same coordinate plane. So some examples, okay, and we'll go into more detail with this later, right? But let's say I have, let me show you 3 different coordinate planes, okay? So let's say, right, these are all coordinate planes. We've got our x and our y axes, I should say, okay? So if there is one solution, all right, then the graphs will look something like this, right, where they cross at one particular point. If there is no solution, that means the lines are parallel. They're going in the exact same direction. Okay, so that would be one option as well. The third option is maybe they're the exact same line. Maybe they look like that, but technically it's like 2 lines sitting right on top of each other, right? That would be an infinite number of solutions, right? Meaning it's the exact same line, so every single point crosses, all right? So those are the types of things we're going to be looking at today. But let's go ahead and get into some examples. For our first one, this is number 1 on your practice. It says find the solution to both equations, all right? Now, I already have, this is the graph that is shown on your practice, and they gave us both equations. So none of that is new. That was all given information. But with that, the solution is going to be where they're crossing each other. So that's this right here. That's the solution, okay? And so that point is -2, -1, right? That's the point on the graph. Now, if it is the solution, I should be able to plug that point into both equations and make both of them true, okay? So that's how you're going to test it. Yes, we can look at the graph, but we also want to practice like actually checking our work, and this is what we would do for that as well. So for this one, I'll keep in green. Let's see, we have x minus 5y equals 3. Well, if our solution is -2, right, we've got x and y. We've got -2, -1, okay? So my x value, I'm going to replace with a -2, and my y value, I'm going to replace with a -1. Well, let's see here. Order of operations, I need to do multiplication first before I work on the subtraction, right? But so this is like saying -5 times -1 if I'm focusing on the sign that's in front of the number. Well, a negative times a negative is a positive. So in this case, I would have -2. And then 5 times 1 is 5. And then -2 plus 5 is 3. So 3 does equal 3. Okay, so it works with that one. Now let me try it with the other one. See, I'll stick with my color scheme here. So my other equation was 3x minus 2y equals +4. That's this one here. And I'm going to plug in those same numbers. So now I'm going to have 3 times -2 minus 2 times -1 equals +4. Well, 3 times -2 is -6. And then -2 times -1 is positive 2 equals 4. And I'm worried now that I wrote this down wrong, okay? So I was about to freak out. This should be a negative 4. And it's like that on your lesson, okay? So I apologize. This is a negative 4, negative 4, negative 4. And this would be negative 6 plus 2 is negative 4, which equals negative 4. So it does check out on this one too. I just checked on my other screen, and it does say negative 4 on there. I miswrote it here, okay? So, but it does work in both cases. So what that tells me is that this is my final answer, okay? That is the solution to the problem. All right, let's try another one. This is number 4 on your practice, and now I'm nervous that I wrote it down wrong too, so let me check that real quick. Let's see, we have y equals negative x plus 6, and then y equals x plus 2. Okay, I wrote those ones down correctly. Now, this one reason why I chose this one is because it says estimate the intersection point of the graphs of the following linear equations in 2 variables. We're not really estimating, we are finding the exact one, so I just wanted you to be aware of that. For some reason it says estimate, but we are finding the real thing. So in this case, again, both of these lines cross, so which tells me there should be just one solution to this system of equations, and that's this one right here. This would be point 2, positive 4. Okay, went to the right 2, up 4. So that's what I'm going to be testing. Now, you could just put that in as your answer. That is where they cross, right? But again, it's good practice for us to check our work. So again, this is like my x value and my y value. So that first equation, we've got y equals negative x plus 6. Well, we've got 2 or 4 as our y value, and then 2 as our x value, but it says that it should be negative, plus 6. Well, negative 2 plus 6 is positive 4, so that one checks out. And then the green one, we have y equals x plus 2, right? Yep, there we go. And so we would say 4 plus 2 plus 2, so 4 does equal 4. Again, that one checks out. So our final answer would be the point 2, 4. That is our solution. Okay? The final one for today is number 2 from your quick check. It says, is negative 2, 6 a solution to the system of these linear equations? Y equals negative 2y equals 10, and 3x plus y equals 0, and y. Okay? So, let me get to that one on my other screen just to make sure. Okay, so first off, we need to figure out yes or no. All right, so with this, I'm going to take both equations. Let's see, first I have x plus 2y equals 10. And here's what I'm plugging in. I'm plugging in this first number for x, the second one for y. So let's see, we've got negative 2 plus 2 times 6 equals 10. Well, 2 times 6 is 12. Negative 2 plus 12 equals 10. Add those together, 10 does equal 10. So it works for the first one. I mean, of course it's going to, right? To work with one, we can solve it. But then this one here, let's see, 3x plus y equals 0. So again, we're going to plug these in. 3 times negative 2, there should be a plus sign, plus 6 equals 0. Well, let's see. 3 times negative 2 is negative 6 plus 6. And then negative 6 plus 6 does equal 0. So we get the same thing on both sides. So they both check out. So in this particular case, we would say yes, it is, because the lines would cross at negative 2, 6. Okay, that would be your final answer in that particular case. All right, so I hope that helps. You also could have tested this by graphing both of them. All right, and see, do they cross at negative 2, 6. All right, if you need extra support, just let me know, and otherwise have an awesome day.